Chairman. Actually, it's my pleasure to meet some colleagues, some friends, and some people actually working in the same field. I think the guys put me after lunch, so everybody was going to fall asleep. So I designed actually the presentation in a way that will wake up everybody, maybe. Yeah, it's not industrial exactly, but when it comes to automation, it's all related. So we'll try to present something and try to see how it is implemented in the industrial sector. It's about automating farms irrigation in Saudi Arabia. It's not new technology, actually. You're not going to see state-of-the-art technology. But what you'll see, actually, that when the size grows, it becomes a matter, becomes a challenge. So first of all, let me give you a big welcome from Saudi Arabia, where we use technology sometimes in a different way. We use cranes to carry camels, not only for construction there. It works. So my name is Sami, as the presenter said. I am originally from Saudi Arabia. I did my master's PhD in Georgia Tech, where actually I worked as a researcher there. We use intelligent control systems, fuzzy logic, neural networks, genetic algorithms. I worked with the Army there for almost 4 years to build autonomous helicopters that will do actually some missions, intelligent missions. I went back to Saudi Arabia. I became the dean of a college for 4 years, then a general manager of a company that used to handle. In Saudi Arabia, actually, it's mainly oil and gas, petrochemicals, minerals. Production, line production is not that so popular. So it's mainly process control. So that company used to handle actually, projects for oil and gas and petrochemicals, where we used to handle Honeywell, Oracle Automation, Schneider Electric. Then I went as a consultant, academic consultant for KFU University to start the College of Engineering there. I finished that mission, they started. And now my son actually sitting back there, he's studying at that college that I started. And then I became a general manager of a company, and still I am jumping like an electron between two atoms, still teaching in academia and also managing a company. So since we are talking about Saudi Arabia is in actually the southwest part of Asia. It's 2.1 million kilometers squared, population 31 millions, and its main resource actually is oil and gas. And that's what the world knows about it. But actually, agriculture is also important there. It used to be actually large, and it's shrinking, unfortunately. So most of the agriculture part actually in the eastern part, where that state called Alhasan is located. The area is almost 500,000 square kilometers, and the population is something like 1 million people. And that's the location of the project that I'm going to talk about. That city actually, or that region, is like a sea of palm trees. In Saudi Arabia, we have something like 25 million palm trees that produce dates. We send it to all over the world. We sell it to the world, actually. And 1/5 of that is located in that part of Saudi Arabia. So this is what it looks like. I know it's growing. They're growing it also here in the United States. But that's if you're talking about two hubs of that production, it's mainly in Iraq and also in Saudi Arabia. So they launched actually an irrigation project, something like more than 40 years back. And King Faisal, he's the man of the oil embargo, if you remember that, He's the one who launched actually that project, where they used open concrete channels to get the water from the water wells to the farms. And a company came, I think if I still remember, from Germany, that executed that project. They installed those open channels, main irrigation channels, and branch channels that take the water to all of the farms. So this is what it looks like. This is a main channel. You can see the water is flowing there between the farms, and branch channels go between the farms, to take the water to each farm. I remember actually when I was a kid, villagers used to jump there, swim, spend some fun time. So everything is okay, everything is fine. What's the problem? Water is depleted. That part used to be actually very rich in water. It's not anymore. Lots of water is gone. Lots of water wells vanished. And we found in that part of the world where the temperature actually in the shade reaches something between 50 and 60 degrees. Under direct sun, actually, there's lots of evaporation. So in some times of the year, 40% actually of the water evaporates. So that's big loss. And also, the water is wasted by the villagers and by the farmers. They, just take the water because they used to flood, actually, all the farms with the water. So there's no what's so-called optimization, in the fields of electrical engineering and automation. So there's lots of water abuse. And that's why they decided actually that we have to make a decision. We have to save water. Water, they don't have it now that much. That's why lots of farms actually vanished. And they tried to replace it with construction. It's a big threat actually for the country because agriculture is so important and it's an asset for the nation. So the solution actually is a $293 million project that started something like 5 years back to replace those open channels with a network of pipelines, and also to use recycled water rather than water from the wells, and automate farm irrigation to optimize the process of irrigation, and apply sprinkler irrigation instead of flooding. Our topic actually is we're going to talk about the automation of farm irrigation today. So they came to that. They call it Alhasan Oasis. It's a big oasis, actually, more than 1 million people there. The agricultural area is something like 80 square kilometers, which comprises something like 20% of the area of that region. They divided that to 10 zones to control it. So it's like, phasing the project, make it smaller phases. So each zone will be handled separately as a separate project. They have actually something like 25,000 farms in that agricultural area. So each zone has something like between 2,000 to 3,000 farms. Then they said, okay, for each zone, we're going to have a water reservoir for irrigation and some tanks where they take the water, it's recycled, and they pump it to tanks that's going to be ready for irrigation. Then have a main pumping station and have some valve-controlled pipeline network, main pipeline network and branch pipeline networks, and apply multi-level zone irrigation control system, and have a master sort of SCADA controller that will control the whole thing. That's generally the way they designed it, and it was actually supervised by the United Nations, actually, because it's a vital project for the nation. So they started removing, I try to make the story short. It's something that's been running for more than 6 years now, and it's going to run for almost also 6 to 10 years more. So they started removing actually those open channels. And the length of the existing, irrigation channel is 1,500 kilometers all over the Alhasan region. So they are removing those open channels and replace it with pipelines. So it's a big contracting project, and they handle each phase separately, as I said. Each zone, separately. So they start digging. It's unstructured environment, but not unstructured data-wise. It's unstructured real-wise, It's farms, the roads are not well established sometimes. Sometimes it's just dirt, sometimes it's paved roads, so they have to handle it, each zone, and handle the engineering problems. So they remove actually the concrete channels and replace it with the pipelines. The total actually design came out to be somewhat more than 1,000 kilometers of pipeline network. So it come to the automation part of this whole network. It's a multi-level SCADA system because of the distance, the big distance of the area. And for academic people who likes actually to handle it's an optimization problem where you'd like to optimize the amount of water that's supplied to the farms. So you can say that XI actually is the amount of water. It's a function actually of the crop type and the farm area and the month of the year because it matters. For example, summertime, they double the amount of irrigation water for each farm. And the ambient temperature. So all those factors has to be handled by the supervisor controller to decide how much water they have to pump in each farm. They have to optimize that. That's not done yet, by the way. This is what's supposed to be. This is the way they designed it. The hierarchy of the control system actually is 4 levels. There's a global SCADA for the whole area for the 10 zones, and each zone has its own SCADA system. And for each main line, and by the way, when I talk about an irrigation line, I'm talking about a line that irrigates something between 30 to 50 farms. And from that line, there's actually farm, branches that feed water to every farm. So it's a 4-level control. From the second to the fourth are existing. The first is still not there. It has not been implemented yet. So where are we right now? 70% of the pipeline has been finished. Still some zones, still working on. Zone 6 actually is finished completely. It's running now. The total area actually is 12 square kilometers. There are something like 3.5 thousand farms in that zone. The project value $43 million, and the water actually is 100% tertiary recycled irrigation water. And there's 3 levels of SCADA control system for zone 6. This is the only zone that's 100% finished now. Still the rest are not. As I said, the project is still going on. So for zone 6, they have a reservoir of recycled water. Actually, it's brought from the pumping station, wastewater system actually in that city. Some water actually is brought from another city. They call the Dammam and Khubar city, something like 150 kilometers away from the city, and it is brought, as I said, it's tertiary recycled water, so it's ready for irrigation. They test it. They add some material to it to make it good for irrigation. They have the tanks, 3 main tanks with a size of 15,000 square meters for irrigation of zone 6. And they have pump station with 6 medium voltage pumps. 4 will be operating and 2 will be standby, just in case. Each pump can pump 500 liters per second. And that's the main pipeline that's connected to the pumping station that actually feeds the water to zone 6. That's actually the room for the MCCs, the motor control center, to control the pumps. And that's level 2 and level 3 of the control system, where that's the main SCADA for zone number 6. And those are the pipelines, the branch pipelines that each pipeline actually is irrigating, as I said, something 30 to 50 farms. So each line has its own controller. It's an RTU that's installed on the line, and they use motorized valves to control how much water actually is pumped in each line. Because everything is scattered around, actually there is radio communication between the main control room and each line. From that, we go actually, so that's the SCADA actually. We got it from SCADA pack from Schneider Electric for Zone 6. Good for Schneider Electric actually, good product for them. And that's level 4, where actually from that irrigation line, we have actually a line that goes for each farm. Now each farm has an RTU that actually it can run as a standalone, or it has to be communicating with the line controller. And right now, the way they designed it, I didn't design it myself, by the way. The way they designed it, they have an RTU that's Tweedo PLC from Schneider at each one, and it's communicating through a Modbus cable to the line controller. Now imagine stretching cables from each farm to that line controller in really unstructured environments. And that RTU actually is controlling, as I said, to a motorized valve that pumps the water to the farm. So each farm actually has that RTU PLC and a motorized valve that's controlled by the RTU. That's how it looks like actually. It has a flow meter and it has a valve. So each farm has one like that. Now we're talking about a project that's going to control 25,000 farms. See the size of it. It's not state-of-the-art technology. It's simple, actually. Maybe some students can design this thing. But when you are talking actually about the size of the project and the way it is designed, this brings us to the challenges of the project. First of all, operation. Is it going to be automatic or manual? And how can you switch from automatic to manual? If you lose electricity actually at some branches, what's going to happen? How would the farmers actually, in the past it used to be manual actually, just valve. Somebody go there, and they get the water, close it. Now it is automated, which means that it's not easy that somebody come and do it himself. Otherwise it's not going to be automated anymore. So how can you switch from manual to automatic? Maintainability. We're talking about 25,000 farms, each farm with an RTU and automated valve. And each RTU is connecting with a Modbus cable to a branch line RTU. And the whole thing actually is communicating via radio communication with the main control room. How many people do you need actually to maintain that? How much training are you going to do to maintain that system? As I said, it's unstructured environments. They are digging actually for the Modbus cables in the dirt. Next day, a crane or whatever is cutting some cables. You need to fix it. How easy that thing is going to be. Spare parts. How much spare parts do you have to keep in the stock? And you know, technology is changing. And what's available today, maybe tomorrow is going to be actually just old technology. Schneider, Rockwell Automation, Siemens, they say, okay, this is not valid anymore. We don't have stock of that. So it's still running. The project is still running, and you cannot control those technology providers, the companies. Expandability. We install RTUs. It has just a limited number of input outputs. But if actually more farms grow in that area, do you have to remove that RTU? Do you have, how can you expand it? Shrink. Some farms, somebody buy 2 farms. Combine them together, become 1 farm now. You have to change the program. So expandability is an issue. Somebody actually grow other crops, So he has to change the course of the water. You have to have somebody to have to go and change the program and to program that. Unless it is taken care of at the early stages, it's going to become, a dilemma actually for that project. Technology. This is government project. They divide the area to zones, and each zone actually has become a tender. So people actually buy the tender documents and they provide. they don't mention that it should be provided by Schneider or whatever it is. So Zone 6 now is Schneider. Zone 5 can be Rockwell Automation, can be Siemens, can be, if you have diversity of technology, how many people do you have to train on those diverse technology? And how much stock you need to keep from that? And, so it becomes a challenge. So this is actually what I tried to share with you today. It can be simple technology, it can be just there's no state of the art of it. But when it grows in size, it can be a big challenge. And people, actually, if I were involved in this project at the very early stages, I would not go with that design, to be frank with you. It's challenging, and people start feeling it now. I'm quite sure that some folks actually today, they presented some technology that can help such a project. And by the way, that's why, the Ministry of Agriculture, they started this center of irrigation technologies, and I'm involved in that. And we're welcoming actually researchers and, technology providers to visit us. We can share some information to help us actually provide better solutions. So I'd like to thank you very much actually for having me today. It was my pleasure to meet you guys. That's my name, that's my mobile number, and that's my email if you'd like actually to save some information, some experience actually that's similar to that. You are more than welcome. Although actually my experience in research was actually in autonomous vehicles and these things, and my job experience was actually in oil and gas. It's not related to water, oil and gas and petrochemicals. But you are more than welcome actually to contact me, and we can share some ideas. Thank you very much, guys.
Thank you. Any questions?
Please.
Yeah, is there like some sort of control center? I know you talked about with the water quality, because like what if there's some contaminants that need to be removed before they go into the crops and maybe contaminate the crops themselves?
Yeah, actually, I just try to make the presentation short. They take samples from the reservoirs actually, and they take samples, at the pipeline branches. They take it to a lab. There's a central lab there that actually see the quality and the material that's in the water. But you're right, it is important. So they are testing actually that water. But there's a hydrometer actually at each line, but it doesn't go down to the quality of the water. They take samples actually, collected samples. Yeah.
Any other question?
Please.
Just curious, you had to take out the concrete open troughs. You couldn't just lay the pipe in the existing troughs.
Yeah, you're right. Yeah, in many cases it became that way actually. But they found that after the growth of the farms, because that was laid down something like more than 40 years back. After the growth of the farms, they found that actually they can take some other routes for the pipelines. So, but you're right.
Okay. Thank you very much. Thank you very much.